Hi guys, it's Mr. Stevens. Sorry I had to go home early. And who knows what's going to happen with the weather and whatever, but looks like we'll probably be having a snow day or two, so the test that is scheduled for Thursday will likely be pushed back. We'll talk about it when we get back, but one thing that might help you is to finish your properties poster. Notice I threw some extra stuff in. Maybe you want to pause the video now to write this down on your poster, or if you don't have it, write it down somewhere. You could add it later. We probably want to add some examples too, or at least one example. And I thought this would be a good thing to do if we do have a snow day. Make sure your poster is good to go, and then likely we'll be using them on the test. So, not a bad idea. What stinks is I just made this whole video. It was about 8 or 9 minutes, and for some reason it got deleted. So I'm going to try to make it even shorter. Here's an example of distributed property. Say you wanted to do 5 times 55. Okay, you could write it down and do it, but what if you were in a store or something, you didn't have a piece of paper, or you didn't have your battery died on your smartphone, you didn't have a calculator? You could do it in your head. And it just means breaking it down to 5 times 5 plus 5 times 50, which 5 times 5 is 25. 5 times 50 is 250. 25 times 250 is 275. Distributed property moves things around and makes it easier. Another way to write this would be it's just 5 times 5 plus 25. I'm sorry, 5 plus 50. Makes it a lot easier. And that's a good example to start with for now. All right, 2 new things here. Mainly it's factoring. Now they say prime factorization. We always called it a factor tree. Write that down in your book, guys, right in the margin there on page 365. The other word we need to know is term. Terms are the parts of an expression that are separated by adding or subtracting, plus or minus. So for example, 12 plus 8, that's 2 terms. All right, and we're going to need this in the next lesson of simplifying expressions. So they break it down. They say, what's the GCF of 12 and 8? Oh, it's 4. Okay. How many times does 4 go into 12? 3 times. How many times does 4 go into 8? 2 times. So this can be rewritten as that. Probably not the best example because it's so easy. You'd say, well, why wouldn't I just do 12 plus 8 in my head? Exactly. All right. Also, notice this little note on the margin that if you break down 6x, it is 2 times 3, but you have to leave the variable in there. All right. These examples on the next page, on the bottom, don't really have that. On the next page, they will. So another thing is, if you can do the GCF in your head, do it in your head. You don't have to do a factor tree, right? Like this one. 3 times 3 is 9, and 3 times 7 is 21. So really, you could rewrite this like that. That's factoring. We can use the distributive property to rewrite this as 3 times 3 plus 7. Now, as a PEMDAS problem, you'd say 3 plus 7 is 10. 10 times 3 is 30, right? Which is the same thing as 9 plus 21, I know, but, sometimes it makes it easier. If you want, you can skip this middle part and go straight to the end. What's the GCF of 14 and 28? 14. So 14 on the outside. 14 times 1 is 14, plus 14 times 2 is 48. See, it might be a lot easier. This one, 80 plus 56, a little bit hard to do in your head. 8's the GCF. 8 times 10 plus 8 times 6. No, whoops. 8 times 6 is 48. Sorry. 8 times 7. 8 times 7 is 56. Remember what we would do with this? We'd say 8 times 10, 8 times 7, add them together, or 17 times 8, which is still a little bit hard to do in your head. All right, now the ones with the variables. Don't forget to include the variable. You need that, right? Like this one, GCF's 4. So 4 on the outside. 4 times what is 16? 4 times 4 plus, now here's the tricky part. 4 times 1 is 4, so 4 times 1x is 4x. But think about what 1x means. It means x times 1, whatever x is. X times 1 is still x. So you don't have to write 1x, you can just write x. Same thing here. GCF is 7, so 7 on the outside, 7 times x plus 6. A lot easier, right? This one, GCF is 6. 6 times 6x, right, is 36x. 6 times 5, 30. The examples on page 366, number 6 is a good reason of why you would do this. This one's pretty easy. 5 times 5 plus 5 times 12 is 60, so there you go. Notice I'm skipping the whole middle part. Say you knew that x was 2 in this one. Then you'd say, okay, 4 times 2 is 8 plus 40. Oh, it's 48, right? Now, we don't have enough information to really know what x is, but some people say, can't I just put the numbers together and say 44x? It doesn't work, right? These are two separate terms because they're separated by addition. 44x means 44 times 2. 44 times 2 is 88. That's not right. We know it's 48. But we can use the distributive property to say, well, this is 4 times x, and this is 4 times 10. So if we add those together, we should get it, but we can rewrite that even more easily as 4 times x plus 10. All right, will it work? Let's plug in x. 2 plus 10 in parentheses means 12. What's 4 times 12? 48. Sure, it works. Might be a lot easier that way. Number 6 is the best example so far of why would you ever want to do this. All right, try these questions. You might pause the video now, give everybody a chance to finish them, and then put it back on and I'll put the answers up. All right, everybody, that's about it for today. The homework, remember, is only the problems on the bottom of 367 and 369, the factoring ones. Update your posters, have a fun snow day, be safe, have fun. And I'll see you when we get back, everybody. Take care.